I'm interested to see your gut reaction for this discontinuity. So starting off, we have a polynomial down in the denominator, and of course, a denominator cannot equal 0. But we have to figure out what values of g make the denominator 0. Most people will just insert values of g and just try to see what equals 0, but that's not how it's supposed to work. Of course, we need to factor this quadratic equation. So using any method you know how, go ahead and factor this out. Oh man, that was a tricky one. But now that we were able to factor that, now of course we can put it back into our fraction, and let's cancel if possible. I can actually see g plus 2 right there, and 7g plus 8 right there. So literally all of our factors cancel out, which when that happens, what does that always equal? Well, it equals 1. So as a matter of fact, f of g does in fact equal 1, but there's a caveat here. Although the terms cancel out, remember our g values still cannot make a denominator of 0. So what value of g makes g plus 2 0? Well, negative 2 plus 2 is 0, so x cannot equal negative 2. And how about 7g plus 8? If we set 7g plus 8 equal to 0, that means 7g equals negative 8, and that means g cannot equal negative 8/7 either. Sorry, that says x equals negative 2. So g cannot only not equal 2, it also can't equal negative 8/7. Now that only leaves the question, what kind of discontinuity is this? Well, in both cases, the denominator was able to cancel completely, except for when the denominator is 0. So that means it is a removable point discontinuity. I hope this short little practice problem helped. I would love to hear your feedback in the comments.